Boom, boom. It is a beautiful day for doing some factoring when the leading coefficient on a quadratic is not equal to 1. All right, so just to help us out, I have some steps over here on the left. And then once we've got our answer, we're going to go check our work in Desmos. And we're going to learn how to do this in a graphing calculator, graphing screen as well. So we have 12x squared minus 2x minus 30. And it says, what we want to do is we want to start with the GCF, or the greatest common factor. And notice it's a 12, a 2, and a 30. So the greatest common factor that's going to pop out of this thing is going to be 2. So I'm going to write 2, and I'm going to divide it out of each one of these individual pieces, which should bring us to 6x squared minus 1x minus 15. Now, the second thing we're going to do is it says multiply a times c. That's not going back to the original equation. That's going back to the piece that we have right now, which is going to be 6 times negative 15. Okay, so it's 6 times negative 15. We can use Desmos for that, but I know that it is negative 90. Okay. So we've multiplied them. And now what we want to do is it says list all the factors that are a times c. So that means list all the factors of a times c, or list all the numbers that multiplied to negative 90. Okay, and we've got 6 and 15 already done. So I could say, well, I've got 1 times 90. One of them would have to be negative. 2 times 45. One of them would have to be negative. 3 times 30. One of them would have to be negative. 4, 5 times 18, one of them would have to be negative. We got 6 times 15, 7 doesn't go in there, 8 doesn't go in there, but I do know 9 and 10 go in there. Now, once we have that list, we need to know, okay, well, what do we do then? It says list all the factors of a times c, which was that negative 90. Now we need to determine which ones add to b. Okay, so there's our template if you need that. So we're going to add to b, and b in this case is negative 1. So 1 and 90 will never get us a negative 1 if we add them. 2 and 45 won't. 3 and 30, if we add them, with any one of them being negative, it won't. 5 and 18 still won't. 6 and 15. But 9 and 10 will add to negative 1 as long as the 10 is negative, right? So once we've got this information, what I'm going to do is I'm going to drop it into the area model. Boom, boom. It always brings us back to this because it makes the life nice and easy. I'm going to bring 6x squared in here, minus 15. And then I'm going to write 9x and minus 10x. Those are those values right there that added to negative 1x. Now, you'll notice over here on the side of the box, it says greatest common factor from the first row, greatest common factor from the second row. So that's what we look for. I've got 6x squared and negative 10x. They both have an x, and they're both divisible by 2. Okay, then what I'm going to do is greatest common factor of the second row. Okay, right here. And so let's do that. 9x and negative 15. Notice they do not both have an x, so we're not going to put an x down this time, but they are both divisible by 3. So I'm going to put a positive 3 there as what we can divide out by. We could do that the same way for the top. So for example, I know that 6x squared and 9x, they both have an x, and they're both divisible by 3. Okay, and then I have negative 10 and negative 15. Both of them are divisible by negative 5. Okay, but I'm not going to put an x because there's no x on that negative 15. So that's one way we can do it. So let's check. 3x times 2x is 6x squared. Negative 5 times 2x is negative 10x. 3x times 3 is 9x. And negative 5 times 3 is negative 15. So we have factored it to be 3x minus 15. Or I'm sorry, 3x minus 5 and 2x plus 3. Now, can we do this on Desmos? Absolutely. It does make life a little bit easier sometimes. So what I'm going to do is I'm going to come right up here. Oh, and I'm sorry, I did forget one thing. Let me go ahead and put that. We have factored it, but we didn't write the original greatest common factor, which is 2. that we took out. So I've got to take that 2 and I've got to put it right there in front of it. 2, 3x minus 5, 2x plus 3. Now let's go to Desmos. Let's plug this beast in and let's do the math, okay? So the first thing I'm going to do is I'm going to come up here and we've taken out the 2. So I'm going to change it to 6 minus 1 and 15. And I'm going to do that because we took out the greatest common factor. And what I'm going to do is I'm going to look for the roots. Now, in this case, the roots are funky looking. They are so ugly. So when I write these factors out, I've got some funky factors to say the least. I'm going to write x plus 1.5. I'm going to use the opposite, and I'm going to use x plus or minus 1.667. And then we have an a value of 6, but that doesn't look pretty, and that's not going to help us out in a little while. So what I do is out of that 6, I say 6 is 2 times 3, and I say which one of the 2 or the 3 will get this number to be a whole number. It's 2. It's 2. So what I write is, well, I have 2 times x plus 1.5, or 2x plus 3. And then I say, okay, well, what about this 3 here? Okay, well, that's the same thing as 3x minus 1.667. So that's 3x. And then if you're not sure if it works, I'm going to take 3 times 1.667. And guess what? It gives me that 5 that I had. So it's going to be minus 5. And check it out. It aligns with our original answer right here, which is 3x minus 5, 2x plus 3. We come back to Desmos, and all we need to do is take out the 2, put it right back up in front, because we did take out a 2 because that was our greatest common factor. Hope that helps. That one had a greatest common factor in it, and in addition, it had a leading coefficient that was not 1.